All right, so we need to look at volume administration, or volume of a fluid to be given. So the volume of a fluid to be given is the volume to be given times the drip set divided by the time in minutes, right? And so you may be required to, well, I shouldn't say you may be required, but you have to be familiar with the equipment that the advanced providers use, and you may have to assist them with these equipments. And one of the things I teach EMTs, which is not really a part of the EMT protocol, is the fluid resuscitation. Right? So starting an IV, running fluids, just for that purpose. No drug, no drug bolus administration, no drug infusion, just fluid resuscitation. So there are three reasons in the EMS we would want to start an IV access. One is to keep the vein from collapsing, KVO. The other is fluid resuscitation, and if we need to give medication to the patient via an IV route. These are the three reasons. As EMTs, the only one I'm going to focus on is fluid resuscitation. So you have you have different types of drip sets. You have your micro drip set and you have your macro drip set, right? So micro would be for controlled administration. The macro would be for patients going into shock that require fluid resuscitation. So they require a large amount of fluids. Now, if it's a micro drip set, it is 30 to 60 drops per mil. If it's a macro drip set, you will see 10, 15, or 20 drops per mil. Now, what does that mean? If it's a 30 or 60 drop mil per micro drip set, it means that it takes 30 or 60 drops to get a mil. That's what it means. And if it's 10 or 15 or 20 drops per mil, it means it takes 10 or 15 or 20 drops to give you a mil, right? So macro is for shock, micro is for medication or control fluid administration. Now, when we are going to give fluid in EMS for the purpose of fluid resuscitation, you have what is called the 3-to-1 rule, right? So your protocol can allow what is called a 3-to-1 rule. What does that mean? It means for every mil or every liter of fluid that the patient loses, we will give 3 times that amount, right? So if you have a patient who you suspect has lost 1 liter of blood, how many liters of fluid should we give this patient? That's pretty straightforward. How much fluid we would give the patient? We'd give the patient 3 liters. If you suspect that the patient lost 2 liters of fluid, how much fluid would you give the patient? Anybody want to answer that?
Would it be 6 liters?
6 liters. All right, good. Right, so that's the 3-to-1 rule. Now, the other rule or other formula that you might come across is we give the fluid based on the patient's body weight in kilograms. So you have the 20 to 30 mils per kilogram for adults, and you have 5 to 10 mils per kilograms for pediatric patients, right? So it can be in mils per kilogram. Now, your protocol might say you need to give bolus, or it might say give a certain amount of fluid over an hour, right? So start with a bolus and then titrate to 250 mils over an hour. Bolus means you give it one time. So if it's 1 liter, you give that 1 liter one time, right? That's what bolus means. It's over an hour or over a specific time frame, then you have to work it out using the volume to be administered formula. All right, so here's an example. Yes, Miss Johnson.
So when you say it is given one time, what do you mean?
You give
Is
it
it like
one
you
time.
drink a glass of water and just gulp it down? Something like that? Okay.
You drink a glass of water and gulp it down. We're talking about IV access. Right? So we're
So
not going to
yes,
give the
I know,
patient.
sir, but I'm just wondering if there's a period of time that it is going to be administered.
There's no time. That's what I'm saying. If it's a bolus, you give it one time. Right? So if I'm giving a patient 1 liter of fluid as a bolus, I'm going to establish my IV access and run the IV set wide open, right? However, for each 500 mils that the patient get, after I run 500, I would assess, then run the next 500, right? But you're giving all of that one time. You understand, Ms. Johnson?
Yes, sir.
All right, good. All right, so example 1. You have a patient that weighs, well, before I even go to the example, you have your 1 liter fluids, you have 500 mils, you have 250, you have 150, and I think you have 50 mils as well, right? Now, 500 mils and 1 liter bags of fluid are used for fluid resuscitation, right? So, and the fluid that we use for fluid resuscitation would be normal saline or lactated ringers, right? Normal saline is 0.9% sodium chloride. It's actually salt water, right? But it's isotonic because it has the same concentration of sodium than what that is in the body. So it is going to remain in the vascular space, which is where we want it, right? So that's the fluids that we use for resuscitation in EMS. So you have your 1 liter, 500 mils. We usually use that for shock fluid resuscitation. Then below that, 250, 100, or 150, we tend to use those more for medication infusion, which is not something I'm going to teach you, right? Because that is outside the scope of this course. Right, so the first example, you have a patient that weighs 160 pounds. The patient requires fluid for resuscitation at 20 mils per kilogram using a 10 drop per mil set. So the formula for fluid administration is the volume to be administered times the drip set divided by the time in minutes, right? So again, with the example, patient weighs 160 pounds, patient requires fluid resuscitation at 20 mils per kilogram using a 10 drop per mil set. You are required to give the first 1,000 mils as a bolus, right? And whatever remain, you will infuse that over an hour, right? So you can approach the formula two ways. You can use the rule of 10. So the patient weight is in pound. We have to convert that to kilogram, right? You can use the rule of 10, or you can divide the pound by 2.2, right? 2.2 kilograms. So 160, using the rule of 10, 160 pounds divided by 2 equal 80. And you find 10% of that 80, which is 10. Sorry, which is 8. Then you subtract that 8 from 80 and you get 72, and you round it off to the nearest 10, because that is easier to work out in terms of giving the patient fluid, because we don't have an infusion pump or a machine that we can be very specific with, right? So we round that down to 70, because 72 is less than 75, right? So we round that down to 70. So the patient weight in kilogram is 70 kilograms, right? And we need to give 20 mils per kilogram. So that's 70 kilogram times 20 mils per kilogram. Kilogram and kilogram would cancel out, so we only have mil remaining. We have 2 zeros, put on the 2 zeros, 2, 7, 14, right? And we need to give, so the patient would need 1,400 mils of fluid. So that's the amount of fluid we need to give this patient. However, example, say you would give 1,000 as a bolus. So you subtract that 1,000 and you will be left with 400 mils. And it's after you've given 1,000 as a bolus, infuse the 400 mils over an hour. So we're going to use the formula to infuse it, right? And using that formula, it is 400 mils times the 10 drops per mil drip set divided by 60 minutes. 1 hour is 60 minutes, right? So we have to convert that 1 hour to 60 minutes. And then we'll work it from there. And you would end up with 66.6 drops per minute, right? Which would work out to 1 drop per second. And that is your example. Any questions? No question? All right. You have a patient that weighs 140 pounds. Work out how much fluid you would give that patient using a 10 drop per mil set. Do that for me quickly.
Please repeat. You just
Let's say you have a patient that weighs 140 pounds. You're going to be giving the patient fluid using 20 mils per kilogram, right? 140, 20 mils per kilogram.
So just tell you the volume. I'm sorry, follow
What
that.
was
So
that? What was that?
no, I'm saying like repeat the. We want it over an hour, or you just want the volume?
Listen to what I'm saying and answer what I'm asking. So don't add to what I've said. The patient weighs 140 pounds. You're using 20 mils per kilogram. You're using a 10 drop per mil set. How much fluid would you give this patient? Yes, Miss Nesbitt.
1,200 ml is a fluid that you would give the patient.
Okay. What the rest get? What did the rest get?
So for the fluid, I get 1,260 mils.
I tell you that you need to round
Didn't
off to the
round off.
nearest tenth. You didn't round
Round
off,
to the nearest.
right? Yes. It's not 1,200, it's 1,200 mils. Don't leave that off. All right. So, Miss Nesbitt, walk me through the process. What did you do?
Well, first I converted the 100 and the pounds to kilogram by dividing by 2.2. So that's
Mhm.
140 divided by 2.2, which is
Right,
63
right.
kilograms, but you convert it to the nearest 10. So since it is less than 65, you just say 60 kilograms,
Right.
right? So 60 kilograms, but basically is 20 mil per kilogram. So if you have
Mm-hmm.
60 kilogram, so it's 60 times 20, which is 1,200 mil.
Mm-hmm. All right, good. That's exactly the process. All right, now your protocol says to give 1,000 of that 1,200 mils as a bolus. And the remaining portion, which is 200 mils, give it over an hour. What would be your drip rate per minute? Per minute. Work that out. Use your formula. Volume to be administered times the drip set, which is 10 drops per mil, divided by the time in minutes. What would be your drip rate per minute?
That's right, sir.
What, hold on. What is that? Go ahead, Miss Nesbitt.
Is me supposed to be doing this, sir?
No, you have your hand up, so I'm
No,
acknowledging.
that was from the first time. Sorry, I should have had it down. But I got the same thing as Mr. Jennings, but it's 33.33 I got.
All right, so we would not be able to give less than a drop in the field. So just round that off to 33 drops per minute.
Okay.
Right? We would round that off to 33 drops per minute. We can't give 0.33 drops with a drip set, right? Manually. That's not gonna work in the field. So just round it off. So that would be correct. I'm not hearing anybody else, What's going on? Yes, Ron.
Just a question to Lorraine. You can go through how you work out that second part, Lorraine, the answer that you just got a while ago, as you did like with the first one.
All right.
Go ahead.
So basically, you're going to say, because it's the total amount is 1,200, but you're going to be given 1,000 as a bonus. So you minus the 1,000 from the 1,200. So that's 200 mil, right? 200 mil. What I normally do is always write the units, because you see when you write the units, you can always know what cancel out what.
Right?
200
Continue.
mil times 10 drop, which is GTT, right? Divided by, because we're infusing it over an hour, but sir want the answer within drops per minute. How much minutes make an hour? 60, right? So right away, we're converting the hour to 60 minutes. So my equation is going to look like this. 200 mil, right, times 10 GTT, which is drops, right, times my equation is going to be 200 times 10 drops, right, divided by 1 mil times 60 minutes, because remember, it's 10 drops per mil is the, what you call it, the drop rate, right? So what sir have it right there? So drop per mil is the drip rate, right? So the equation becomes 200 mil times 10 GTT divided by 1 mil times 60 minutes. Right away, you start cancel out the mils them. And you're going to end up with 200 times 10 drops, which is 2,000 drops divided by 60 minutes. So when you get your answer, the amount is going to, the unit is going to be drops per minute. So that is 33 drops per minute. Get that, Ron?
Thank you very much. Wow, impressive.
And that was recorded. All right. So I'm going to disappear for a bit because my connection is back up. So I'm going to log off on my phone and then log in on my laptop. Don't.
Did everybody get that? It's
Yeah, we're
done.
good. We're good.
Yes, Lorraine.
I am back. Everybody hearing me?
Yes, sir.
All right,
Yes,
good.
sir.
I'm finally back in business. All right. Yes, thank you for that explanation, Ms. Nesbitt. All right, so that's it for drug calculation. There's nothing more I need to go through in terms of formula. So you have the drug calculation formula sheet. Go through the formula. Make sure you understand the formula. You'll be getting the drug calculation paper to complete as soon as I come off the this session today. So look out for that. You people want another example to move on? Well, not an example, a problem for you to work out, not for me. Want
Yes,
another
sir.
one?
Yes, sir.
Yes, sir.
Sure.
All right. All right. You have a patient. You have a patient that weighs 180 pounds. You're required to give 30 30 mils per kilogram. How much fluid would you give this patient?
30 what there?
30 mils per kilogram.
It's 2400 mils, sir.
Okay. Anybody get anything different? Are the same?
Same thing, sir.
Okay. All right. So you're required to give 2,400 mils. Your protocol says give the first, well, your protocol says give 2,000 liter as a bolus. What am I saying? 2,000 mils as a bolus. And the remaining 400 mils, you are required to give it over an hour using a macro drip set at 15 drops per mil. What would be a drip rate in minutes? Type your answer. Should be finished by now. That's a one response. That's a two. Waiting on the others. Make sure you get it, you actually get it and don't type what the others typing, you know. Make sure you're working it out and getting it. Waiting on the others.
Sir, just review the details so I can catch up back on where I left off.
What details specifically? Who was that?
01, sir.
Yes, what detail you're asking about specifically?
Where I should do the subtraction for the first total that I've received.
Mm-hmm.
Yes.
So you need to give the patient 2,400 mils. You're required to give 2 liters out of that 2,400 mils as a bolus, right? Whatever remains, you will give it over an hour using a macro drip set at 15 drops per mil. Miss Johnson, what's going on? What is going on, Miss Johnson?
Nothing, sir. I got what everybody else got. 100 drops per minute.
And you understand the working out part of it?
Yes, sir.
All right, good. Where are you, Rowan?
Still here, sir. Working on it.
You understand that 2 liters is the same as 2,000 mils, right?
Yes, sir.
All right, good. So using the formula, right? If the patient requires 2,400 mils, 2 liter out of that is the same as 2,000 mils, so you would be left with 400 mils, right? Using the volume administration formula, it's 400 mils times the drip set, which is 15 drops per mil, divided by the time in minutes, it's 1 hour, so 60 minutes. And if you work that out accordingly, you should get 100 drops per minute. Now, if we're giving this patient 100 drops per minute, how many drops per second would that be? Roughly. So it's 100 drops per minute. How many drops per second?
Is that 6,000?
No, no. No, no. No, no, no.
No, sir.
6,000.
You said that it's per second. Oh, sorry. Sorry, sir.
One, so
Come
about
on.
2 drops per second.
2 drops per second, right? 2 drops per second. We're not talking about 6,000.
That was an error.
Right, 2 drops per second. Right, and so when it comes to drug calculation, always double check, always double check. And as Miss Nesbeth pointed out, you do not leave off your measurements, right? Because if you just give me 100, I'm gonna mark that answer incorrect, because that can be a fatal mistake, right? So work with your measurement. All right, so that's it for drug calculation. If you have any questions, you can send them to me. No, right? You can definitely send them to me via text or email if something is not clear. Now, the next thing I want to look at, I will be teaching you how to start IV access. It is up to your organization if they allow you to do that, but I will teach you how to start an IV and run fluids. That's it, which is fairly straightforward. You just need to know why it is that you're doing it and why we're using a specific type of fluid. All right, so next, let's finish up the ECG. Let me zoom out. So we're going into the ECG stuff. Basics of the ECG. Need to finish that now. I need to get to the waveforms. All right. All right, so based on what I've covered so far in cardiac monitoring, when would we consider putting a patient on a cardiac monitor? That's a question. Yes, Mr. Jennings.
When there are signs of an acute MI,
Okay.
would that be good?
So is it only a patient with cardiac history you would consider putting on a cardiac monitor? That's a question to everybody. Is it only cardiac patients we put on cardiac monitor?
No, sir.
Okay, so outside of cardiac patients, which are the patients we would consider to put on a cardiac monitor?
Patient with chest pain or major trauma to the chest, sir.
Patient with what? I heard chest pain and something else. In a nutshell, it's any patient that's critical. right? So once you have a patient that's critical, they need to be on a cardiac monitor, right? But specifically, if the patient has a cardiac history or a possible cardiac complication or respiratory complication, you definitely need to do cardiac monitoring for these patients, and eventually you have to obtain a 12-lead ECG, right? Now, when we do cardiac monitoring, how many electrodes can we use? Let's see if I remember anything from when I mentioned it. That's a question. When we're doing cardiac monitoring, how many electrodes?
10.
That's for ECG, cardiac monitoring. So it's 10 electrodes for ECG, not for cardiac monitoring. Yes, Miss Johnson.
I think you said 12, sir.
That's
4.
for ECG, 12 lead ECG.
Was
So
it
we're
4, sir?
using,
You said 4, sir?
yes, 4. So it can be 4 electrodes, it can be 5 electrodes, right? But generally in the field of EMS, it's four electrodes. However, even though it is 4 electrodes, how many leads can we look at?
3.
3, right? So we can look at 3 leads. So I want you to zoom in on the diagram, especially on the triangle. Everybody seeing that triangle? Yes, Miss Nesbitt.
Please clarify what is an electrode and what is a lead.
All right. The electrode is what captures the current in layman terms, right? So it captures the current at one point. A lead shows you how the current move. Everybody understand that concept? Everybody get that?
Yes, sir.
No, sir.
Right. So the
No, sir.
electrode, who don't
Sir.
get that?
Me not get it, sir. You said
Me not get it.
electrode is something where make the current move, and the lead are what you seen on the monitor.
No. Come again. The electrode, when you put it on the chest, it picks up an electrical current. You get
Is
that
it
part?
the round things? The round things
Yes.
are lead.
No, the round things that you stick on the patient are electrodes, right?
Okay.
That is your electrode that is picking up the electrical current. The lead is how the current moves from negative to positive, right? That's the lead. So the lead will show you how the current is moving and captures a specific area of the heart based on the direction that the current is flowing. Everybody get that concept?
Yes.
Yes,
Yes?
sir.
All right, good. We seen the square? What you remember about square? Triangle. My brain is getting tired. We seen the triangle?
Yes, sir.
Sir.
All right.
Yes, sir.
Let me see if I can do this a different way. All right, so on this triangle, you're seeing lead 1, you're seeing lead 2, and you're seeing lead 3, right? So this is showing the 3 limb leads of cardiac monitoring. And remember, your green electrode would be the 4th electrode that stabilizes the current. Now, if you look closely, you'll see RA, LA, and you can see LL, which is left leg, right? RA's right arm can be right shoulder as well. LA, left arm, can be left shoulder. LL, left leg, and sometimes you'll see RL, which is right leg. Now, if you look at the diagram, you will see where lead 1 starts. So lead 1 starts at R, the right arm, and it travels to the left arm, right? So where it starts would be negative, where it ends would be positive. And let me just move out from this slide for a bit. Let's see if I can draw something on this. Okay, pencil. All right, so I want you to picture it this way. Everybody seen my circle?
Yes, sir.
Yes, sir.
Yes, sir.
All right, now look at the line that I'm drawing. Right? So everybody see the circle, everybody see the line going through the circle, yes?
Yes, sir.
Yes, sir.
Yes,
All
sir.
right. All right, now the circle represents the heart, right? So the circle represents the heart, and the current is moving from the right arm to left arm. It's moving that direction. So it's passing through the heart. Wherever the current ends, there is a camera on that side, right? And we can draw the camera. So good. So that's a camera. So if lead 1 starts from the right arm and it ends in the left arm, so it's moving from right arm to left arm, which side would the camera be looking at? So which side is the camera facing?
It's facing the left side of the heart.
The
Good,
left.
good. So when you look at lead 1 on your cardiac monitor, you are looking at the left side of the heart. Everybody understand that?
Yes, sir.
Good.
Yes, sir.
All right. Now, so that's lead 1. Lead 2 is from the right arm to the left leg. So picture the current moving this way, right? R is here, camera is down here. Which side the camera looking at?
Left leg.
The
Would it
apex.
would it be the right inferior heart, the right wall of the heart, the ventricle?
We don't want to get too technical. It would be inferior. So apex would be right, but it's inferior, right? So if I asked you what side of the heart does lead 2 look at, it would be inferior. So lead 1 is the left side of the heart. Lead 2 is the inferior portion of the heart. All right. Now lead 3 is from the left arm to the left leg. So it's left arm, left leg. So the current is moving this way, and my hand is not steady, but anyway, right? So again, the camera is down here, right? That's your camera. Which side of the heart would that be looking at?
I don't know, sir. That looked like the apex of the heart on that side.
It's still inferior. You must say don't get technical.
Still inferior.
Sorry, it's
All
still
right.
inferior. Sorry, it's just that the
But more
complete a little bit
inferior.
more
It
over
could
to
it
the
be
right.
could
All
it
right.
be more
Hold
inferior
on,
left,
hold on.
sir?
Too many persons talking at once. Put up your hand. I can't hear all of you at once. So if you, yes, Ron, go ahead.
Yes, sir. So it's still inferior, but the only
Yes,
difference is that it is a little bit more to the right.
yes, right? We don't want to get that specific with cardiac monitoring. So it would be simply inferior, right? So these are your limb leads. Lead 1 is from right arm to left arm. Lead 2 is from right arm to left leg. Lead 3 is from left arm to left leg, right? And I'm going to go on camera for a sec. It's taking a while. Let me share. Ooh. Are you able to see me on cam?
No, sir.
You people not seeing me
Yes,
on
sir.
camera?
Yes, sir.
All right,
No,
let me
sir.
switch.
Yes, sir.
Everybody seeing me now?
So you're very
Yeah.
small.
All right.
You have to touch it, Miss John. Miss
No.
John, just press on it and it gets big.
Just touch the camera and I'll get
Okay.
big. All right. So I'm actually at work, right? Big secret. Anyway, so what I do to remember it is this is how I remember the lead. So I use my right arm and I run it across my chest like that. So that's lead 1, right? So I know that it's starting from right and going to left. Lead 2, I run my hands like that. So it's going from my right arm down to my left leg. Lead 3, you start on the left arm and go down. That's how I remember it. So it's lead 1, lead 2, lead 3. All right, coming off cam. We got that?
Yes,
Clear.
Yes,
sir.
Yes,
sir.
sir.
Good. So let's see if you have learned anything. Which patients do we use cardiac monitoring for?
Any critical patient, persons who are in cardiac arrest or respiratory complications.
All right, good. When we're doing when we're doing cardiac monitoring, how many electrodes are we using?
4.
We are
4 electrodes, right? So it would be 4 electrodes. Even though it can be 4 or 5. So when you go in the when you go in the hospital, you'll tend to see 5 electrodes more than 4, right? And the 5th electrode is the apex electrode. You will see that in the hospital. In the field, we use 4 electrodes: right arm, left leg, right leg. Those are the 4 electrodes. The one on the right is the green electrode, right? So right leg is green electrode, that's a ground lead that stabilizes the current. Now, even though it is 4 electrodes, how many leads can we look at when we're doing cardiac monitoring?
3.
3.
Good. And these leads are lead 1, 2, 3. Lead 1 looks at which side of the heart?
Left.
Left side. Lead 2,
Right.
Inferior.
inferior. Lead 3,
Inferior.
Inferior.
good. Commit that to memory. Make sure you remember that. All right? Remember that. Important information. All right. Now, with cardiac monitoring, we can only see lead 1, lead 2, and lead 3. So we can only see the left side of the heart and the inferior portion of the heart. Are we seeing the entire picture?
No.
No. So would this be adequate for a patient that you suspect is having some type of cardiac complication?
No, sir. You would go to
Okay.
ECG.
Right. So we're not seeing the entire picture. And if you have a patient with cardiac history and obvious presenting signs, the 3-lead monitoring, you're going to put them on your 3-lead monitoring. But eventually, we need to get a bigger picture. We need to see what's going on in other places. This is where a 12-lead ECG comes into play, right? So this is where we would obtain a 12-lead ECG or 12-lead electrocardiogram. Now, the cardiac monitoring, it is dynamic. So you put your electrodes on the patient and you watch the rhythm on your monitor, right? You watch the rhythm on your monitor. With the ECG, it is static. So you're gonna be putting your electrodes on the patient and then you print out a graph that captures the electrical activity within the heart on that graph, and it will show you different locations in the heart. Right? All right. Now, I have a diagram that I can show you that on. Yes, Miss Nesbitt.
You said that the ECG is static and cardiac monitoring is what? So the C
The
word.
cardiac monitoring is dynamic.
Dynamic. Thanks.
Good. All right, so I may have to bring up another slide, so just give me a sec. I'm gonna have to share my screen because I need another PowerPoint. Oh, I got carried away. It's actually 5 p.m. So we will take a 10-minute break. So we're gonna take a 10-minute break and then we will resume.